Let's continue with our second subject. It's quadratic equations. So a quadratic equation is an equation of the second degree, meaning that the highest exponent of this function is 2. Okay, the standard form of a quadratic equation looks like this: ax squared plus bx plus c is equal to 0. As you can see here, we have x as our variable, and here its exponent is equal to 2. So the only requirement here is that we have to have this x squared instead of in order to call this equation as a quadratic equation. So here a, b, and c, they are our known values, and here this a cannot be equal to 0, because when it's equal to 0, this becomes 0, so it does not make this equation as a quadratic equation. Here our x is the variable, or we can call it our unknown. We don't know it yet. So let's see how do we solve these quadratic equations. So first method is factoring, solving by factoring. To solve a quadratic equation by factoring, first you should put all terms on one side of the equal sign, leaving 0 on the other side. What do I mean by this? Let's look at this example and you will understand better. Here we have x squared minus 6x is equal to 16, right? So to factor this equation, first we should put all the values on one side, and the other side we should only leave 0. So here we have x squared minus 6x. So I put this 16 to this side, and when I put this to other side, it goes like minus 16, which is equal to 0. Okay, now I can factor this equation. How do I do that? So we factor first our constant to its 2 factor, and these factors should give us minus 16. Don't forget this sign. It should give us minus 16 when we multiply this, when we multiply the factors, and when they are summed up, they should give us minus 6. Let's try, for example, here minus 16 and plus 1, right? So when you multiply minus 16 and plus 1, you get minus 16, right? But when you sum them up, what you get, minus 16 plus 1, it's minus 15, which is not equal to minus 6. I should get minus 6 instead of in order to solve this equation. So let's try another one. Another factors, it's minus 8 and plus 2, right? So when I multiply these two, I get minus 16. When I sum them up, minus 8 plus 2, it's minus 6. So as you can see, I found both of them. So these are the right factors for us to solve this problem. So here, how I write these two, I write them as x minus 8, okay, times x plus 2 is equal to 0. So I factor them here. Now these after that I will equal these two. I will make them equal to 0. Okay, so when I make them equal to 0, because why? Because when you multiply something by 0, it will give us 0, right? So which means x can be equal to 8, or x can be equal to minus 2. So as you can see, we got 2 values of x. So which means our solution set is equal to minus 2 and 8. Okay, so these are our solutions. Let's check them by inserting in the original equations. For example, let's put this minus 2 instead of x here. So here I will get minus 2 square, it's 4, right? Minus 2 times 6 it's minus 6 it's plus 12, and minus 16. 4 plus 12 it's 16, minus 16 it's equal to 0. You see, so we got the 0. So let's try 8. So here 8 squared it's 64. 8 times 6 it's minus 48, minus 16, right? So here 64 minus 48 it is 16, minus 16 it's equal to 0. So as you can see, these both values they are correct for my equation. So since this is a quadratic equation, okay, the solution set has to be with two factors. If it will be the cubic equation, let's say, then the solution set has to be with 3 factors. Okay, it goes the same amount with the exponent here. So our solution for this question is -2 and 8. Let's continue with these examples. In our first example, we have 3x squared plus 16x plus 5 is equal to 0. So here the coefficient of x squared is not equal to 1. As you can see, we have also 3 in front of this x squared, right? So this is not like the same as we did before. So what you do in these cases? So you also factor this 3x squared, okay? After that, you also do the same thing for our constant, and then I will cross multiply the values of the factors, and as a result, when I cross multiply and I add them together, I should get 16x. So let's try it. So here we have 3x squared, and how can I factor this 3x squared? I can factor this as x and 3x, okay? So 5, it's 1 and 5. So when I cross multiply, okay, I get 5x plus 3x, right? So I don't get 16x. So this means I should change the order of these two or these two. Okay, let's change this. Let's make this 3x and this x, okay? So when I do that, let's try. This is 3x times 5, it's 15x, and I have here x times 1 plus its x. So this is equal to 16x, which is the same we have here. So which means these are the right factors for our question. So let's continue. After this, it's actually the same thing. You just when you write them, we write them in the same order, which means I write them as 3x plus 1 times x plus 5 is equal to 0. And after this, you know how to solve it. I make them equal to 0, and from here I get x1 as here, let's do this. 3x plus 1 is equal to 0. 3x is equal to minus 1, and x is equal to minus 1 over 3. So our first solution is minus 1 over 3, and our second solution is minus 5, right? When you equal these to 0, you will get x as minus 5. So these two are our solutions. Let's look at this example. Here we have m minus 5x cubed plus m times x squared plus 7x plus 2 is equal to 0. If this equation is a quadratic equation, find the solutions. So this is a quadratic equation, which means the highest degree of the variable should be 2, right? It cannot be higher than 3. Sorry, it cannot be higher than 2. So here as you can see, we have x cubed, so we should get rid of this term here. So which means this value should be equal to 0, right? So in order to get rid of this term, so which means m minus 5 is equal to 0. From here we get m as 5. Okay, so after this everything is same as we did before. We put just m here as 5. It's 5x squared plus 7x plus 2 is equal to 0. So here we factor 5x, it's 5xx, and here this is 2 and 1, right? So when I cross multiply these, I get 5x plus 2x, which is equal to 7x. So we get the right order here. So let's write them as like this: 5x plus 2 times x plus 1 is equal to 0. So 5x plus 2 is equal to 0, 5x is equal to minus 2, and our first solution is minus 2 over 5. Okay, this is our first solution. Our second solution is here, minus 1. So our solution set is equal to minus 2 over 5 and minus 1. Let's continue with the discriminant. So discriminant is a very important topic when it comes to quadratic equations. You have to know these conditions and this formula in order to find your solutions when it comes to quadratic equation questions. So this is called discriminant because it can discriminate between the possible types of answer. So here we have, let's say this is our quadratic equation, ax squared plus bx plus c is equal to 0, and our discriminant is equal to b squared minus 4ac. So this sign is also, this is the d in letter D in Greek language, and this is also called as delta, or you can just call it as discriminant. So this discriminant is equal to this b squared minus 4a, 4 times a times c. So when this discriminant is bigger than 0, it means we get two real solutions. Okay, so when it is equal to 0, we get just one real solution, which means both answers are the same. And when this discriminant is less than 0, we get a pair of complex solutions. It means our answer will include imaginary numbers. Okay, let's continue with the examples so you will understand the logic better. Let's continue with this example. Here we have m plus 4x squared plus 2mx plus m minus 2 is equal to 0. If this equation has two real solutions, what is the greatest possible integer value of x? So it says it has two real solutions. So we get two real solutions when we have our discriminant when our discriminant is bigger than 0, right? So our discriminant has to be bigger than 0. Let's find our discriminant. What was it? It was equal to b squared minus 4ac. So b squared, it's here. This is a. Okay, this is b, and this is c as a whole here. So b squared, it's 2m, so it's 4m squared minus 4 times our a is m plus 4 times c, it's m minus 2. So when I do that, I have to get something bigger than 0, okay, because it says this equation has two real solutions. So after that, let's continue. Here we have 4m squared. Let's just multiply these two together. We will get minus So this is m squared, okay, minus 2m and plus 4m minus 8, and this is equal to m squared plus 2m minus 8. So I will multiply these by 4. It is minus 4 actually. It's minus 4 m squared minus 8m, because here we have plus 2m and you multiply by minus 4, it's minus 8m, and here we have minus 4 and we have minus 8, and then when you multiply these two you get plus 33. So this has to be greater than 0. So after this will cancel out each other, and from here we will get 32 is greater than 8m. When I put this minus 8m to other side, it becomes plus 8m, and here 4 is greater than m, which means the greatest possible integer value of x is 3 in order to get this solution. Okay, let's look at this example. Here we have x squared plus square root of 3x is equal to 0 and x is s. So here, as you can see, there is no constant, right? So we can write this expression as x in the parentheses of x plus square root of 3 is equal to 0. Why? When you multiply these two, these x and x, you will get x squared. When you multiply this x by this, you will get square root of 3 times x. So after this, it's very easy. So to get 0, this x can be 0, or this expression can be equal to 0. So our first solution is 0, and our second solution is, when you make this equal to 0, you will get minus square root of 3. So these two are our solutions for this example. So let's continue with our second method. It is the quadratic formula. Many quadratic equations cannot be solved by factoring. In this case, we have a formula that we can use. So, for example, in these examples, when you look at them, okay, when you try them by solving by factoring, actually you will see that you will not be able to factor them. So in this case, we will use this quadratic formula. So first step is we will find the discriminant of the equation to see if it has real solutions or not. So what was our discriminant? It was b squared minus 4ac, right? So first we find them, and after that we will look if it has real solutions or not. After that, our second step is after that we will apply these quadratic formulas. So for our first solution, it's x1 is equal to minus b plus square root of discriminant over 2a, and our second solution is equal to minus b minus square root of our discriminant over 2a. So just these signs, they change, and this becomes our first solution and this becomes our second solution. So you have to memorize these formulas, because these are very important sometimes, because you will not be able to solve your questions by factoring, so you will need to use these formulas. So we will solve some examples about this, so you will understand this topic better. Okay, let's look at our first example. Here we have x squared minus 4x plus 1 is equal to 0. So when I try to factorize this equation, I couldn't find anything. Here when I do like x, and here minus 1, it can be minus 1 or plus 1. When you try, you will see that you will not be able to find the solution for this equation by solving by factoring. So what you should do, you should apply the quadratic formula. In order to apply the quadratic formula, first you need to find your discriminant, right? So what was our formula for that? It was b squared minus 4ac. So let's see if we have real solutions for this equation. So here our b is equal to minus 4. So this is equal to minus 4 squared. It is 16 minus 4 times a is 1 times c is 1. So this is equal to 16 minus 4, which is equal to 12. And 12 is greater than 0, which means our equation has two real solutions, right? So let's apply our quadratic formula. Our first solution is equal to minus b plus square root of our discriminant over 2a. So minus b, it's 4 because b minus 4, so minus times minus, it will make it positive 4, and plus 4 plus our discriminant is 12, right? So it's square root of 12 over 2a. 2 times 1, it's 2. So from here, 12, I can write it as 4 plus 12, it's 2 square root of 3, right? Because 2 square, it's 4, 4 times 3, it's 12 over 2, which is equal to 2 plus square root of 3. So this is our x1, our first root. So let's find the another one, the second one. So it is minus b. So we only change this sign, okay? So we make it minus square root of our discriminant over 2a. So from here, this is actually same. You just change the sign. So here we get 4 minus 2 square root of 3 over 2, which is equal to, when you divide all of them by 2, you will get 2 minus square root of 3. As you can see, this is our second solution. So when you see this kind of examples, first you need to find your discriminant, so you will see if you have real roots or not, and after that you will just apply the quadratic formula. Let's look at this example. Here we have 5x squared plus 2x plus 1 is equal to 0. So what is our first step? First step, we will find our discriminant, right? So it is equal to b squared minus 4ac, which is equal to our b is 2. So 2 squared, it's 4 minus 4 times our a is 5 times 1. So this is equal to 4 minus 20, which is equal to minus 16. Minus 16 is less than 0, right? Which means our solutions will include imaginary numbers. So how we do that? So in this case, our formula is actually it is the same. Okay, it's minus b plus minus square root of our discriminant over 2a, right? This was our formula. So here, instead of our discriminant, we will put minus 16. Okay, same. So minus b, it's minus 2. This is our b, this is our a, and this is our c, don't forget. So it's minus 2 plus minus square root of minus 16, okay, over 2a. A is 5, so 2a is 10. So in this case, we should write this as, so square root of minus 16, we can write this as 4i. So you as you remember, this is the imaginary number, imaginary number square root of minus 1, right? From imaginary number subject, as you remember, this is equal to square root of minus 1. So I can write this value as this. So after that, I just put this value instead of square root of minus 16. So our answer will be x1, x2 will be equal to minus 2 minus plus 4e over 10, which is equal to minus, you just divide them by 10, and from here you will get minus 0.2 plus minus 0.4i. So this will be your solution for this question. So whenever you have your delta, your discriminant less than 0, it is just, you will know that your solutions will include imaginary numbers. So for that, just remember, instead of a, we use this, so which means this minus square root of minus 16 is equal to 4i. So this is the process you need to follow to get the right answer in this kind of questions. Let's continue with our another topic. It is the sum of the roots and the product of the roots. So as you know, when we have quadratic equations, usually we get two roots. So when you want to sum up these two roots, you have a special formula, and when you want to multiply these two roots, you also have another special formula for that. So let's see. X1 plus x2 is equal to minus b plus e. So here this is our b, this is our a, right? So when you want to find its summation, it is x1 plus x2 is equal to minus b over a. So when you want to find the product of the roots, it's equal to c over a. So these two formula you have to know in order to find the answers for questions when they ask you sum of the roots or product of the roots. So let's see this example. Here we have x squared plus 5x plus 6 is equal to 0, and it's asked that x1 square x2 plus x1 times x2 square. So here what can we do? We can take parentheses as like this, x1 x2, right? Because these two terms, they have x1 times x2. So I write here as x1 x2. So in parentheses I will write x1, because when I multiply these two I will get this term, plus I write also here x2, because when I multiply these two I will get this term. So after that I will apply these formulas. Okay, so x1 times x2, which is equal to c over a. So our c is 6 over our a is 1, right? And after that times x1 plus x2, which is equal to minus b over a. So minus b, it's 5 over a, which is equal to 1, right? So this is 6, this is minus 5. When I multiply these together, I will get minus 30, and this will be the solution for our example. Here we have 2x squared minus 6x plus k minus 1 is equal to 0. 3x1 minus x2 is equal to 9. So what is k? So in this kind of questions, they give us this equation, right? So here these are x1 and x2. They are the roots of this equation. So I know another two formulas, right, for the roots, which was, the first one is x1 plus x2 is equal to minus b over a, and another one is x1 times x2, which is equal to c over a, right? So which one I can use instead of to get any root of these two, one of them, okay? So which one should I apply? So here, as you can see, I know this formula. So here when I look, minus b over a, this is our b, this is our a, so I can simply get an integer, and I can simply find this x1 from these two equations. So let's do that. So here this is given, right? 3x1 minus x2 is equal to 9, and I know x1 plus x2 is equal to minus b over a, which is equal to minus 6. It becomes plus 6 over 2, because our a is 2, which is equal to 3, right? So this is equal to 3. So when I sum them up together, from here I will get, these will cancel out each other, so I will get 4x1 is equal to 9 plus 3, it's 12, and x1 is equal to 3, right? When I divide both sides by 4, I will get x1 as 3. So this x1 is one of our roots, so which means I can apply this value to this equation, and I can easily find the value of k. So let's do that. Instead of x, I write 3, okay? So it is 2 times 3 squared minus 6 times 3 plus k minus 1 is equal to 0. So from here, 3 squared is 9, 2 times 9 it's 18, minus this is 18 plus k minus 1 is equal to 0. These will cancel out each other, and from here I will get k as 1. So as you can see, when you find one of the roots, after that it is very easy. You just go and put this value instead of x, and from that you will get the value of k. Here we have 1 over x minus 2 plus 1 over x plus 2 is equal to x over x plus 1. What is the sum of the roots of this equation? So in order to find the sum of the roots of this equation, first we will do our basic operations to get our equation equal to 0, right? We have to get our quadratic equation first. So how I do that? I first make this denominator equal to each other, these two. So I will multiply this by x plus 2, and this one x minus x plus 2, x minus 2, and from here we will get x plus 2 when I multiply this, plus x minus 2 over, here we have x squared minus 4y, because when you multiply these two you get this, right, the difference of two squares. So from here this is equal to x over x plus 1. So here these will cancel out each other, and then from here I will get 2x over x squared minus 4, which is equal to x over x plus 1. So these x, I cancel them out, and I do cross multiplication here. So from here I will get 2 times x plus 1, which is equal to x squared minus 4. Okay, so from here this is 2x plus 2, which is equal to x squared minus 4. So this is x squared. Okay, so I put this 2x to other side, or it doesn't matter actually, because I will make them equal to 0. So it's x squared, this becomes minus 2x, and this minus 2 becomes this plus 2 becomes minus 2, and we have here minus 4 also. When I add them up together I will get minus 6, which is equal to 0. So as you can see, we got our quadratic equation. Now everything is much easier. What was the question? The sum of the roots. So how do we find the sum of the root? It's minus b over a, right? Which is equal to minus b. It's 2 over a. It's 1. So our answer is 2. When the roots are given and the equation is asked. So here they will give us the roots and we will try to find the equation. So let's say they give us the roots as x1 and x2. Okay, so in order to write the equation, okay, you will use the formula for the sum of the roots and the product of the roots. How we do that? So it will be something x squared minus something x plus here something our constant is equal to 0, right? Because why? The form of quadratic equation is something like this: ax squared plus bx plus c is equal to 0, right? So we have to have something with x squared, x, and our constant. So why did I write minus here? Because here we will write, let me write with another color. Here we will write our summation of our roots. It's x1 plus x2. Why? Because what was the formula for this? It was minus b over a, right? So here our a is 1. So here this is our b, right? So this is minus b over a. That's why we write here minus and here the value of the sum of our roots. So here we will write the product of our roots, x1 times x2. Why? Because this is equal to c over a, right? So which is equal to, actually this is our constant. This is our constant. So here, since a is equal to 1, our constant will be equal to x1 times x2. That's why we write this like this. So let's look this example. Here x1 is equal to 2 and x2 is equal to 5. Write the equation. So let's apply this logic here. So we will have x squared, okay, minus x1 plus x2. So which is equal to 2 plus 5, 7x plus, and the product of these two, which is 5 times 2 is equal to 10, and this is all equal to 0. As you can see, when you know the logic behind this, it's very easy to find the equation when they give you the roots. So this is the process you need to follow to get the right answer in this kind of questions. In this example, the roots are given as 1 plus square root of 3 and 1 minus square root of 3. So here first what we do, we just write these x squared minus something x plus something is equal to 0, right? So our equation will be like something like this. So here, this part, we write the sum of these roots, x1 plus x2, which is equal to, when I sum these up together, it is, these will cancel out each other, and 1 plus 1, it will be 2, right? After that, here we write the product of these two roots, which is equal to x1 times x2. So here these roots, they are when I multiply them with each other, this is the difference of two squares, right? So it will be, let me write it here. So it will be 1 plus square root of 3 times 1 minus square root of 3 which is equal to, this is the difference of two squares, so it will be 1 minus 3, this is equal to minus 2. So here this will be minus 2, and our equation will be x squared minus 2x minus, this plus will remove because we found this as minus 2, and let me write it here one more time. It's x squared minus 2x minus 2, which is equal to 0. So this is our equation.